Today is 9, 10, 15. Okay, so whenever you're doing dimensional analysis, what you're looking at is to see if the equation is valid based on, based on whether or not the units say something true. Okay, so the first thing you're going to do is just substitute in the units for each of the dimensions you're measuring. So delta x, distance, displacement, is meters. What are the units for velocity? Meters per second. So we've got meters per second, and that's being multiplied by time. What are the units for time? Seconds. So then we have 1/2 a, units for acceleration are? Oh. Meters per second squared. There we go. And it's being multiplied by t squared. So the units for that are seconds, and that's squared. So then you can start canceling out units. Shrink that. Move this up. So we notice immediately that that's going to cancel that. So meters equals meters plus 1/2. Well, meters per second squared cancels seconds squared. Gesundheit. So you have meters equals meters plus 1/2 meters. What you're thinking about is, can I add these things? If you end up with things that are being added, can you add two quantities in meters? Yes. So that's legitimate, that's legal. Okay? Because when you add meters to meters, what do you get? Meters. So we can, at this point, just get rid of any numbers that are left. Meters equals meters. This is a valid expression. So we would say, yes, this checks out dimensionally. Okay? Try the other ones on your own, and then if you want more, I'll give you a FIP quiz on these if you want tomorrow, like a real FIP. When you're doing dimensional analysis, when you come up with something that is meters plus meters, remember, you're only looking at the units here. So if you add 10 meters plus 5 meters, what are the units for your answer? Meters. So in terms of dimensional analysis, meters plus meters just gives you meters, because you're only looking at how the units would behave. You're checking for dimensional consistency. Okay? Does that help? Yes. Something that trips people up. So if I have meters per second divided by meters per second squared, what's the rule for dividing fractions? Invert and multiply. So that, and that makes life so much easier. That becomes meters over second times second squared over meters. Okay? To perform that function, invert and multiply. Well, so now you have seconds, meters second squared over meter seconds. We end up with seconds. We have 2 delta x over a delta x times 2 is equal to v
delta t.
Delta t.
Delta t where
the sorry.
X is.
Yep, that makes more sense. Okay, so when we put our units in, we have 2 times meters over meters per second squared times seconds times 2 equals meters per second times seconds. Okay, so let me shrink and move. The next step, we can start by doing this. 2 meters over. We multiply these out, we get meters.
It's not.
I know. Multiply them, that bottom out, and we get meters seconds over seconds squared times 2. We can multiply out the other side. We get meter seconds over seconds. So we know those seconds are going to cancel. We know that's going to go away, and that's going to become just seconds. so now, as our next step, let me shrink this again. I'm going to have 2 meters over meters seconds equals meters. So then, if I invert and multiply that side, I have 2 meters times seconds over meters
You forgot the
equals meters. Okay, and I forgot that too. Okay, so now I have 2 meters seconds over 2 meters. That goes away, that goes away. Seconds equals meters. Is that true?
No.
No. Don't forget that on the bigger batter conversions on the back, on number 4, on the conversions, you're going from meters per second to kilometers per minute. That's not, or squared. That's not meter squared. My mistake. So as a general reminder, whenever you're going from something like, grams per cubic centimeter, let's fix that. When your units are a derived quantity, like grams per cubic centimeter, remember that that's 25 grams for every 1 cubic centimeter. Now the tricky part is that 1 cubic centimeter is 10 to the negative second meters times 10 to the second meters times 10 to the negative second meters, not 10 to the second meters. And then, of course, your grams, that's easy. So 10 to the third grams is equal to 1 kilogram. So if you're going into kilograms per cubic meter. So this is the big key, is remembering to set that up. Okay, FIP quiz tomorrow.